the topics today. So it will take one more class to complete the chapter. Okay. So today I will discuss the Bohr's atomic model, de Broglie equation. Okay. And if the time left, then we will also do the Heisenberg uncertainties.
So,
Okay.
ma'am, for the exam, it's only coming to what we did last class?
Which exam, बच्चों? आपके स्कूल के एग्जाम?
No, ma'am, now in tuition, the weekly test.
Okay. So no, the previous class.
Till the
Till the
previous
previous
class,
class.
whatever.
Yeah. Yeah. What we
Okay.
have done till the previous class, not from
Okay.
today's class.
Okay.
Yeah.
Ma'am, can I leave?
Why, Hafsa?
Ma'am, we are in chapter 1. How can you teach chapter 2?
No, in this is C2 batch, bache, and in C2 batch we are doing with atomic spectra and this atomic model. आप तो वो first batch से हो ना, Hafsa? Which
Yes,
in
ma'am.
which we are doing the first chapter, right? But this is not your class.
Yes, ma'am.
This is second batch, which is in which we are doing the second chapter.
Ma'am, they sent me link, so I joined.
Okay, let me check with the team. Just a second. Okay, hello everyone. Hafsa, so from the next class, from today you can continue this batch. And आज हम बोहर्स मॉडल पढ़ रहे हैं, so you can continue with us because जो भी आपका topic left हो गया है, so we will cover this in the extra class. Okay, one-on-one session. Okay, Hafsa.
No, ma'am.
Why बच्चे? What happened? This is an individual topic. आज मैं new topic start कर रही हूँ, so आपको कोई problem नहीं होगा. Because from the next class inshallah we are going to start the new chapter, तो आप ये join कर सकते हो आपके batch. And for this chapter, whole chapter, we will arrange an extra class for you. Okay, one-on-one session.
No, ma'am. That previous chapter, half chapter left for me.
Yeah, तो वो तो होगा ही, वो आपका जैसे चल रहा है बैच वो चलेगा. But for this chapter, we will arrange an extra class. Okay? Hello.
No, ma'am. I'm not okay with this.
You can continue with this, बच्चे. I'm here for you. We will arrange an extra class, one-on-one session, जिसमें आप सिर्फ single मैं आपको separately पढ़ाऊंगी. Okay? तो आप यहाँ से there are 4 to 5 topics left. तो यहाँ से आप कंटिन्यू कर सकते. Now tell me, is it okay or not?
No, ma'am.
Just a second. Just a, okay, Hafsa, if you are not comfortable, so you can leave the class. Okay, अगर आप चाहो तो you can
Okay,
join the
ma'am.
class from the next class. Okay, because we are going to start the next chapter. Okay, which is periodicity. Okay, बच्चे. Okay, please leave the
Okay, ma'am.
class.
Okay.
Okay. Okay, sorry, Asha and Sunidhi for the inconvenience caused. Okay,
Okay.
so what were your doubts? So Aisha, you were not there in the last class, right?
Yeah, ma'am, the timings were changed and we were outside, so I couldn't get the notification on time.
Oh, okay, okay, no problem. So you have a problem with threshold frequency, right?
Yeah,
So what is threshold energy? So it's very easy. Threshold energy is the minimum amount of energy, right? Minimum energy which is required by any electron to show photoelectric effect. You know very well, you have gone with the recording. Have you seen the recording?
yeah, ma'am, I did.
Okay. So you know very well what is photoelectric effect, right?
Yeah,
So the minimum amount of energy which is required by any electron or metal to show the photoelectric effect is known as its threshold energy. Okay, a threshold energy ko we will also call work function. Threshold energy is also known as work function. Okay, and if we are writing threshold energy, so we will write E naught for that. Okay, we denote threshold energy as E naught and work function as capital W, right? So threshold energy is equals to H nu. Okay, because E is energy is what? Energy is the Planck's constant, the product of Planck's constant and frequency, right? So it's a threshold energy. It's also energy, right? So E naught is equals to H into nu naught. And what is nu naught here? So nu naught is the threshold frequency. Okay, because naught is here, so it's a threshold frequency. And we know that frequency is equals to speed upon your wavelength, right? So for this threshold frequency, it will be c upon lambda naught, and lambda naught is your threshold wave. Okay, so we have two formulas over here. So E naught is equals to h into nu naught. Okay, if the threshold frequency is given, you can calculate the threshold energy. Okay, by multiplying it by your Planck's constant. And if the wavelength is given, so you can calculate the threshold energy by using this formula, h into c upon lambda naught. Lambda naught is threshold wave. Got it?
yes, ma'am, got it. Thank you.
Now see, if work function is low, means the threshold energy is low, then it is very easy for the electron to eject. ओके इलेक्ट्रॉन के लिए बहुत इजी हो जाता है इजेक्शन के लिए राइट इफ द वर्क फंक्शन इज लो एंड इफ द वर्क फंक्शन इज हायर देन it is quite difficult for electron to eject. Okay, means there is a inverse relationship between the work function and their ejection of electron. Okay, if the work function is low, then the ejection will be easier, right? And if the work function is, you can say it is higher, then it is very difficult for for the electron to eject. Okay, now see, this point is very, very important. Okay, if energy of light is greater than your work function or threshold energy. Okay, अगर energy light की ज़्यादा है work function और threshold energy से, then the extra energy it will be converted into kinetic energy of electron. Okay, and that extra energy which is converted into kinetic energy of electron, it helps in the ejection of electron. Okay, it helps in the ejection of photoelectron. Okay, and this extra energy is equals to energy of light is equals to work function plus kinetic energy, right? So from here, kinetic energy will be equals to energy of light minus your work function. Okay, and we know that energy is what? Energy is h into nu, right? So and your work function means E naught, right? And E naught is also equals to h into nu naught. And nu naught is what? It's a threshold frequency, right? So from here, when you substitute this, you will get h into nu minus nu naught. Nu is the frequency, right? And nu naught is your threshold frequency. From this equation, you can calculate the kinetic energy of ejected electron. Clear, Aisha?
Yes, ma'am, clear. Thank you.
Okay, so today we are going to start with the Bohr's model. Bohr's atomic model. Now, do you remember the last model? Which scientist has given the last model of last atomic model? Do you remember its
Thompson,
postulates and limitation? Yes, Einstein.
Thompson's atomic model.
Rutherford atomic model, which is Rutherford.
Oh,
Yeah, it's Rutherford. And what was the limitation of Rutherford model?
uh, It couldn't explain the stability
Yeah, it couldn't explain the stability, right?
and the
He does,
distribution of electrons and their
yeah,
energies.
yeah. He doesn't tells us about the energy levels, right? He failed to explain the energy levels. Okay, so on that limitation, the Niels Bohr worked. Okay, उसी limitation पे Niels Bohr ने work किया and he gave some postulates. Okay, now see, let's see what are those postulates. So first, he said that electron is revolving in circular path. Okay, he said that Niels Bohr said that electron is revolving in circular path around the nucleus, right? And those circular path is known as orbit or shell, or he said it has a energy level. Okay, he just gave the term energy level. So energy, electron is revolving, right? So is a orbit, and this is a nucleus, right? This is a nucleus, and electrons are revolving around this orbit. Okay, around this orbit, and this circular path is known as orbit or shell, you can say, or this is energy levels. Okay, so इसी types की बहुत सारे orbits होते हैं like K, L, M, and shell, and these are according to the energy levels. Okay, so energy levels के according there are different type of shells or orbits. Second postulate was that he said that if the electron is present in a particular orbit, right, then it can neither radiate energy nor absorb energy, right? If an electron is on a particular orbit, right, if it is present on a particular orbit, then it will neither radiate energy, right, means ये lose भी नहीं करेगा energy and ये gain भी नहीं करेगा, absorb भी नहीं करेगा energy when it is present at a particular energy level, right? But if there will be a transition, right, means if this electron jumps from lower state, right, if it is jumps from lower state to higher state, right, lower से higher state की तरफ jump करेगा, then the energy is absorbed. Okay, and when, for example, there is an electron and if it drops, okay, if it drops from higher state, this is the higher state, for example, it is N4 and it is N1, right? So it jumps from, not jump, it just drop from higher state to the lower state. For example, ये N2 पे आ रहा है, right? So energy is released in this case. Okay, so remember these 2 points. If the electron is present at a particular orbit, then it can neither radiate energy nor absorb energy, right? Means energy of each orbit is fixed. Energy हर एक orbit का fix है. But when electron is jump, right? When electron jumps from lower energy level to higher energy level, means if there is a transition, right? If there is a transition between for lower energy level to the higher energy level, then the energy is absorbed. Okay, जब lower से higher की तरफ electron jump करे, then energy is absorbed. But when it drops from a higher energy level to the lower, right? Higher से lower की तरफ, then the energy is released. Okay, just remember these points. Clear?
Yes, ma'am.
Yes, ma'am.
Yeah. And energy of electron changes with change in its orbit, right? When the electron changes or transitions from one state or one energy level to the another, then its energy also changes, right? Then the energy of electron also changes. Okay, so next postulate was the transition of electron from one orbit to another is accompanied with change in energy. Okay? Means when the transition occurs, means when the electron moves from one orbit to another, then its energy also changes. Okay, so these points I have already discussed. When an electron drops from a higher state to a lower state, so the energy is released, right? And when the electron jumps from lower state to higher state, then the energy is absorbed. And yeah, see, the absorbed or evolved energy is always equal to the difference in energies of two orbits. Okay, energy change means the change in energy will equals to E2 minus E1. And what is E2? E2 is the energy of higher state and E1 is the energy of lower state. Okay, so in दोनों का difference is your the change in energy. It will give you the energy difference. Okay. So, and we know that energy is equals to H nu, right? So E2 will give you H nu 1 minus H nu 2, right? So accordingly, you will find. Clear?
Yes, ma'am.
Yes, ma'am.
Okay. Next, Niels Bohr, he gave a frequency term, right? He said that frequency of each radiation means if there is a radiation, then there may be frequency, right? जहाँ पे भी radiation होगा तो वहाँ frequency होगा, right? And the frequency of that radiation which is absorbed or emitted when transition occurs, right? जब transition होगा तभी तो absorb होगा energy या emit होगा, right? Transition means when the electron jumps from one level to another, or when it drops from one level to another. It means transition, means the changes, right? Change in the energy level, change in the orbit. Okay. So if the radiation frequency of radiation absorbed or emitted when transition occurs between two stationary states that differ in energy by delta E, right? तो हम delta E से differ करते हैं. Delta is E. What is delta E? So it is the change in the energy level. Change in the energy level, which is E2 minus E1. E2 is the higher state energy level and E1 is the lower state. Okay. So, and what is the frequency of that radiation? So frequency is equals to delta E upon H, because we know that delta E is equals to H nu, right? So from here, nu will be equals to delta E upon H, right? Delta E is the difference in energy levels, right? And H is your Planck's constant. So we nu is equals to delta E upon H, and nu is what? Nu is Bohr's frequency, right? It is because it was given by Bohr, so it is known as, this expression, whole expression is known as Bohr's frequency. Okay, and delta E is what? E2 minus E1 upon H. Clear?
Yes, ma'am.
All these formula you have to remember, right? आपको याद होगा, then only you can do the numerical, because this chapter is very lengthy. बहुत सारे concepts है, बहुत सारे topics, right? So you have to remember and you have to revise again and again all the topics. Then only you can do the numericals. Okay, because from this chapter numericals will come.
Ma'am, can you explain this point again?
This frequency term,
Yeah.
yeah. So I said that whenever there is a radiation, then it is accompanied by some frequency, right? And yeah, and the frequency of any radiation is absorbed, whether it is absorbed or emitted. Absorbed किस case में होगा? When the electron, it jumps from lower to higher level, right? Lower to higher level. So in the case, it will be energy is absorbed. When the electron drops from higher level to lower level, then it will be emitted. Energy lose होगा, emission होगा, right? Energy evolve होगी. So that means transition हो रहा है वहाँ पे. Transition means changes, right? The changes of energy levels or changes of orbit. Okay. So in that case, the frequency of radiation occurs between two stationary states, right? States तो दोनों stationary है, they are in rest. Energy levels, they are in rest, but the electrons are moving. Electrons jump कर रहे हैं from one energy level to another energy level, right? So there will be whenever, see the postulates, I just tell you the transition of electrons from one orbit to another is accompanied with change in energy, right? So whenever there is a transition of electron between the orbit, then there will be a difference in energy, right? And energy, difference in energy is given by delta E. Delta is what? It is a difference in energy, or you can say change in energy. Okay. And we know that delta E is equals to H nu, right? H is Planck's constant and nu is frequency, right? So from here, nu will be equals to delta E upon H, right? So that's what I have written over here. And what is nu? So nu here is Bohr's frequency. Why? Because it is given by Bohr. Nu is equals to delta E upon H, right? And what is delta E? It is the difference in energy, right? So difference in energy कहाँ से कहाँ तक हुआ है? फॉर एग्जाम्पल E1 से E2 की तरफ हुआ है, right? Means first energy level to second energy level, and this is the final one. Initially electron यहाँ पे था. Initially electron was on this orbit, means n is equals to 1, and it jumps from n is equals to 1 to n is equals to 2, right? Means first orbit से second orbit पे वो उसने jump किया, right? So energy, the final energy is E2 and the initial energy is E1. Okay, so final minus initial, E2 minus E1 upon H. Okay, and E2 is what? Final energy level, means your high energy level, minus your lower energy level divided by your Planck's constant. Okay, so that's the formula to calculate the Bohr spectrum. Clear, Aisha?
Yes, ma'am. Thank you.
Okay. So have you guys written till here?
No,
If
ma'am.
not, you can take the screenshot. Just a second. First, let me explain this point also. See, the line spectrum, which we will see further, later discuss करेंगे what is the spectrum and what is line spectrum. So line spectrum is obtained due to this electronic transition, right? These electron की जो transition होते हैं from one state to another state, due to this the line spectrum is obtained. ओके ये जो लाइन स्पेक्ट्रल लाइंस आते हैं जब हम पढ़ेंगे इस एटॉमिक स्पेक्ट्रम में हाइड्रोजन स्पेक्ट्रम में, so these line spectrum is obtained due to the electronic transition. Just remember this is due to the electronic transition from one state to another state, right? Because electrons just move or just transition from one state or one level to another level. Due to this the spectrum caused. Okay, spectrum is obtained, which we will see further. Clear?
Yes,
Now
ma'am.
quickly just write it down, or just quickly you can take the screenshot. Done?
Ignore.
Okay.
Yes, ma'am.
Can you just scroll one line higher? Yes, ma'am. Just can you scroll the first line, the sentence? Yes, ma'am.
Done? Okay. Now see the mathematical analysis of Bohr's model. So first, let's see the radius of an orbit. How to calculate the radius of an orbit according to Bohr's model. So Bohr, he said that the radius of any shell, any number of shell, is equals to m square into h square upon 4 pi square into me square into z. Okay. So what is n? So n is a shell number according to Bohr's model. Okay. And h is what? H is the Planck's constant 4 pi square. It's again a constant term. And me square, it is the mass of electron. Okay, and z is your atomic number. Okay, so you can see over here this h square upon 4 pi square, me square, all these are constant terms, right? So when Bohr put all the values of these terms, so he just find this 0.529. Okay, so he have just simplified the this equation for us to use this in the numerical part. Okay, so he just simplified this equation, and the equation is Rn is equals to 0.529 into n square upon z, which is in angstrom, right? N is what? N is your shell number, and z is your atomic number. So this is the formula for calculating the radius of any orbit which is having a certain atomic number. Okay, for example, here's a question, let's see. So calculate the radius of first orbit of hydrogen atom. Okay, so we have to calculate the radius of first orbit. So first orbit means n is equals to 1, right? And it's for hydrogen atom. So hydrogen atom, so atomic number of hydrogen is 1. So Z is also 1. Okay, now let's calculate. So it's R1, right? Radius of first orbit. So R1 is equals to 0.529 into what is n is n? So n is 1. So 1 is square upon your 1, which is in angstrom. So R1 will be 0.529 angstrom. Okay, so that's how we just calculate the radius of any orbit of any atom. Now see, if R1, okay, first orbit radius, right, when it is for hydrogen atom, right, R1 of hydrogen atom is equals to A naught. Okay, A naught is any variable when it is equals to A naught. So the formula will be Rn is equals to A naught into n square upon z. Okay, A naught into n square upon z. This is the case when the R1 of hydrogen atom is equals to A naught. Okay, only for hydrogen atom. So this will be equals to A naught into n square upon z.
Okay.
Yes, Aisha, any question? Okay, see the question here. If the radius of first orbit of hydrogen atom is x picometer, right? So radius of first orbit of hydrogen atom is x picometer. What does it mean? So it means that A naught is given. A naught is x picometer, right? Because when if this is the we have discussed it. If R1 of hydrogen atom is A naught, right? So here the radius of first orbit means R1 of hydrogen atom is x pm means A naught. Then the value of third orbit of lithium atom will be. So how to calculate this? So we know that lithium atom it is, so Z will be equals to 3. Atomic number of lithium is 3. So let's write. So R3 means we have to calculate the value of third orbit. So R3 will be equals to R3 of lithium atom will be equals to A naught, right, into what is n square? So n for lithium atom is, it's for third orbit, right? So n will be equals to 3. So 3 square means 9 upon z means 3. 3 upon 3 ones are 3, 3 threes are 9. So it will give you 3 A naught. Not A naught. The value of A naught is x, right? So we can substitute it over here. So x into, so 3x will be your answer. 3x picometer. 3x picometer. Okay, so that's how we just calculate if the R1 of hydrogen atom is A naught. Okay, A naught it can be any variable. Okay, so if the R1 of any hydrogen atom is given, then we can calculate the radius of any orbit of any atom. Okay, for example, here हमें क्या निकालना था? So here the value of third orbit of lithium atom we have to find. And the radius of first orbit of hydrogen is given, which is A naught. A naught is equals to x picometer. So we have just substituted it in the equation, right, in this formula, and we have calculated the R3 of lithium atom, which is 3x. Okay, यहाँ पे x की जगह पे कुछ value भी हो सकता है, right? x की जगह पे कुछ भी वैल्यू दे रखा हो सकता है. So accordingly, you have to just substitute this in the formula and you have to calculate the value. Clear, both of you?
Yes, ma'am.
Yes, ma'am.
Okay, just quickly write it down. Then we will see what is the formula for energy, how to calculate the energy of electron in different orbit, which was given by Niels Bohr. Done?
Yes, ma'am.
Okay, now see the energy of electron. So the formula, there are different formulas according to the unit. Okay, if we will use different units, so there is a different formula for energy of electron. Now see, if the energy of electron for different your orbit, you can say, is equals to minus 13.6 into z square upon n square electron volt per atom. Okay, if we have to calculate the energy in electron volt, then we will use this formula, right? Minus 13.6. And if we have to calculate the energy in kilojoule per mole, okay, kilojoule per mole में अगर आपको find करना होगा, then we will use this formula minus 1312 into z square upon n square. Okay, and if we have to calculate this in only joule, so we will use this formula minus 2.18 into 10 raised to the power minus 18. Okay, z square and n square is common in both. Okay, in all, this is constant, z square upon n square. Okay, these term is changing, minus 13.6, minus 1312, and it is minus 2.18 into 10 raised to the power minus 18. Okay, so you have to remember these. Okay, if it is electron volt, then we will use minus 13.6. If it is kilojoule, then we will use minus 1312. Then if it is joule, then we will use this minus 2.18 into 10 raised to the minus. And these are two constant. These are constant. Z square upon n square is constant. Okay, and we know that 1 electron volt is 1.6 into 10 raised to the power minus 19 joule. Okay, so these formulas and these terms are very important for the numerical. Okay, so you are going to use frequently these formula and this term in the numerical questions. तो आपको याद होने चाहिए सारे formulas. Okay, yeah, and one more thing, this negative sign. Why this negative sign is here? Right. So this negative sign tells us about the attraction between the nucleus and electron. Yeah, ये negative sign क्या बता रहा है? So it tells us about the attraction between nucleus and electron. Clear? Okay, so just write down this formula. Done?
Yes, ma'am.
Okay. So let's see. Now, here's a term ionization energy. What is ionization energy? So it's a amount of energy which is required to remove electron, right, from its ground state to the infinity, right? Ground state से infinity तक जो ले जाने में electrons को जो energy लगता है, that is known as your ionization energy, right? So what is ionization energy? The amount of energy which is required to remove electron from its ground state, okay, to the infinity level. For example, if the energy it is in ground state and the electrons are transition from ground state to the infinity level, right? And the energy which is required to remove this electron from this ground state, this is the ground state is the initial energy, and the final energy is your infinity, right? In infinity the energy जा रहा है, so it is known as final, and this one is initial. So what will be the ionization energy? So ionization energy is the amount of energy which is required to remove the electron from this ground state to the infinity, right? This is ground state and this is infinity. So that's the ionization energy. And the change in energy is equals to final minus initial, right? And this change in energy is known as your ionization. This will give you the ionization energy, right? This change in energy, it will give you the ionization energy. So it is equals to final minus initial. Final means your infinity energy minus your initial means ground state energy. And the energy which is associated with the infinity energy, right? Infinity तक जो जाने में energy लगता है, that is your zero, always, right? E infinity is zero. E infinity is zero. Minus. Now tell me what is the E? What is the formula of E? Energy in electron volt. So energy, it is in electron volt is minus 13.6 minus 13.6 into Z square upon N square, which is in electron volt, right? Now see, this minus minus, it will give you positive, plus 13.6 into Z square upon N square. Means the change in energy or ionization energy, it is in positive form, which is 13.6 into Z square upon N square electron volt. Okay. Accordingly, you just calculate, you can calculate this in the different units, which is in kilojoule per atom, or you can calculate it in joule. Okay. So accordingly, you can just substitute the value of energy over here and you can calculate the value in positive form, right? So this change in energy is also known as your ionization energy, and which is equals to the final minus initial one, and it will give you a positive, right? The ionization energy is positive here, 13.6 into Z square upon N square electron volt. For example, if we have to calculate the ionization energy for hydrogen atom, right? So for hydrogen atom, what will be the ionization energy? So it will be equals to 13.6 in positive form, 13.6 into Z square. Z for hydrogen is 1, right? So it's 1 square upon. And for example, if we are talking about the first orbit, so it will be 1 square. 1 square upon 1 square electron volt. So it will give you 13.6 electron. Ionization energy for hydrogen atom is 13.6 electron volt. Okay.
Yes, ma'am.
Yes, ma'am.
So can I scroll down? Just quickly write it down. Done?
Yes, ma'am.
Aisha, done?
Yeah, ma'am.
Okay, now see, here's another formula to calculate the velocity, right? So velocity of electron of any orbit is equals to 2.18 into 10 raised to the power 6 into z upon n, which is in meter per second. That's the formula, only formula for calculating the velocity of electron for different shell number. Now see, just remember this. Don't be confused in this. Energy is directly proportional to z square upon n square. Okay, z square or n square upon n square we just use in energy formula, and in radius formula we use n square upon z, right? N square upon z, and for velocity it is z upon n, right? So you just have to remember these. For radius n square z, and for velocity z upon n, and for this energy it is z square upon n square. दो z और n दोनों के ही स्क्वायर में होता है, right? Okay, so don't be confused in this. Okay, so here's a question. Energy associated with the first orbit in the hydrogen atom is minus 2.18 into 10 raised to the power minus 18 joule per atom. Okay, see the unit. It is in joule per atom. So we have to calculate the energy in joule. So what is the energy associated with the fifth orbit? Okay, question समझ आया? So in question, what is given? So energy associated with the first orbit of hydrogen atom is minus 2.18, right? And we have to calculate the energy which is associated with the fifth orbit. Okay, so we have a formula. E is equals to, because it's in joule per atom, right? So we will use the formula for joule. Joule के लिए जो formula था, we will use that. So what was the formula? So it was energy is equals to minus 2.18 into 10 raised to the power minus 18 into z square upon, because it is energy, right? Energy है तो z square upon n square. It is in joule. Now substitute the value. So z here is, z is first, right? Because hydrogen atom की बात हुई, z is 1 and the n is your 5 because fifth orbit. Now substitute the value, minus 2.18 into 10 raised to the power minus 18 into 1 square upon 5 का square is 25. Minus 2.15 into divided by 25 into 10 raised to the power minus 18 joule. Solve it. So you will get minus 0.0872 into 10 raised to the power minus 18, right? And this will give you minus 8.72 into 10 raised to the power minus 22. Okay, so that's the energy which is associated with the fifth orbit. Any doubt?
No, no, ma'am.
Okay. Written?
Yes, ma'am.
Yeah, ma'am.
Okay. Okay, so I need some space, so I'm erasing this. Okay, now see, if there is a transition, a case of transition means, for example, if it is N2, second orbit, right? And the electron jumps from second orbit to fifth orbit, right? Means the transition is between second to fifth orbit, right? So this N2 will be the initial one and this will be final one, right? ये transition का case है, right? So this is a case of transition when the electron jumps from lower state, which is 2 to 5, right? Higher state पे jump कर रहा है. So there will be a transition. You can see over here the transition हो रहा है यहाँ पे, right? So this will be your initial one and this is your final one. So in this, so the change in energy is equals to final minus initial, right? And final, what is the formula for energy? So it's E naught into Z square upon your, what is the final one? So final shell number is 5. So it's 5 square minus E naught into Z square upon your 2 square. 2 square was the initial one. Now what is E naught here? See, because there is no unit. Okay, I'm not using the unit over here. So E naught is, you can, yeah, you can write in the place of E naught. If you have to calculate the energy in electron volt, so you will see, just a second. If you have to calculate the energy in electron volt, so you just put minus 13.6 in the place of E naught, right? And if you have to calculate the energy in kilojoule, so you have to put this value minus 1312 in the place of E naught. Okay, that's why I am using E naught here because वहाँ पे कोई specific unit नहीं है, right? किसी भी अगर particular unit में आपको find करना है, then use this formula accordingly. Accordingly, you will use this formula in the place of E naught. Okay, so E naught will be equals to minus 13.6 electron volt. In the case of electron volt, E naught will be equals to minus 1312 in the case of kilojoule, and E naught will be equals to minus 2.18 into 10 raised to the power minus 18 joule. Okay, so you will choose these values accordingly. Okay, तो आपको किस वैल्यू में, किस यूनिट में फाइंड करना एनर्जी, अकॉर्डिंगली यू विल पुट द वैल्यू. Okay, so that's why I'm using E naught here. Now see, E naught are common in both these. So E naught into Z square upon 5 square minus Z square upon 2 square. Or you can, just a second, you can take Z square common. You can take Z square because E naught into Z square upon 1 upon 5 square minus 1 upon 2 square. Right. So from here, I have just derived another formula to calculate the delta E value, right? Difference in energy levels. So if we are calculating these values in electron volt, for example, electron volt. So I will just put E naught in the place of E naught. I'm just putting minus 13.6 into Z square 1 upon 5 square. And what was 1 upon 5 square? 1 upon 5 square क्या था? So 5 square was final one, right? So I can just write NF, right? Final shell number of final transition state, the square, minus 1 upon 2 square. 2 क्या था? So 2 is the initial transition state, right? Initial state. So I can just write Ni for it. Ni square. Okay. It was in electron volt because I'm using minus 13.6. Okay. So it's electron volt. Now see, can I take negative sign as a common? Right, bracket से अगर मैं negative sign लूँ तो negative negative it will become positive and you will get 13.6 into z square. Right, अगर यहाँ से negative sign लोगे तो it will be inverse, like I will write ni square first minus 1 upon nf square. Right, so this negative negative it will become positive. So that's the value of electron volt. right? This is the formula to calculate the change in energy in the case of transition, right? And what is Z square? Z is the atomic number. Ni is the initial state, right? Initial state is square, and this is the final state square, and this is in electron volt. Now, similarly, if I have to calculate this in kilojoule, okay, so I will write 1312 in the place of 13.6 into Z square, and this will be similar, n initial square minus your final state, and this will be in kilojoule per mole. Similarly, in joule, it will be 2.18 into 10 raised to the power minus 18 into Z square 1 upon Ni square minus 1 upon Nf square. Right, what is the unit for this? So it's joule. Simply it's a joule. Joule per atom. Clear? Any doubt in any step? Aisha and Sanidhi?
No, ma'am.
Mom.
Okay, so please write it down. So this is the case when the electron is in transition state. Okay.
I can scroll.
Sanidhi, have you done?
Yes, ma'am, done.
Okay. Okay, see. So there are some limitations of Bohr's model. Okay. So what is the limitations? So Bohr, Niels Bohr, he failed to explain the line spectra of atoms or ions with more than one electron, right? He just explained the that type of line spectra of that atom which has only one electron, right? He was not able to explain the line spectra of atoms which are having more than one electron, right? So that's a major limitation of Bohr, right? Bohr's model. And second limitation was that he doesn't explain, or he fails to explain the line spectra details of hydrogen atom, right? ये उन्होंने ये नहीं कहा था, फॉर एग्जाम्पल सी द हाइड्रोजन एटम when it is exposed, when the line spectra of any atom, it is exposed to magnetic or electric field, right? So in that case, the splitting of a spectral lines, it will be in it will just multiplied. Okay, for example, just a second. So see what he said, Bohr model, he just predict a single spectral line, right? He predict a single spectral line for each electron transition. Because उन्होंने तो सिर्फ वन इलेक्ट्रॉन की को प्रिडिक्ट किया था कि ओनली वन इलेक्ट्रॉन के स्पेक्ट्रा दी थी, राइट? सो ही एक्सपेक्टेड और ही जस्ट प्रिडिक्ट single spectral line for each electron transition, right? But further, scientists he experimented and he revealed they reveal that these spectral lines often split into multiple lines, right? When they are exposed to electrical or magnetic field, right? Again, I'm repeating what he said. Bohr model, predict that that single spectral line for each electron transition, right? But further, scientists came and they said that accordingly, they said that they revealed that these lines, these spectral lines, when they are exposed to magnetic or electric field, right, they split into multiple lines, right? They split into multiple lines, जो कि बोहर ने नहीं कहा, right? Multiple fine lines में वो split हो जाता है, which was not explained by Bohr, right? So that's the major limitation of Bohr's model, right? He doesn't explain the details, spectra of hydrogen atom, detailed spectra of hydrogen atom. Okay, and yeah, like third limitation was that he fails to explain the Siemens effect or Stark, right? Now here's a new term which is Siemens effect and Stark. So Siemens effect क्या होता है? So just remember, Siemens effect, it is when the line spectra, right? When the any line spectra, when it is exposed to magnetic field, right? When it is exposed to magnetic field, then they just split into a group of fine lines, right? Then they split into a group of fine lines, which is known as Zeeman effect. Clear? What is Zeeman effect? Got it?
Yes, ma'am.
Aisha?
Yeah, ma'am.
Okay. So Zeeman effect is when the line spectra, it comes close with the magnetic field, or when it is exposed to magnetic field, then that line spectra, they split into multiple fine lines. Okay, multiple fine lines when it is influenced by magnetic field. So this process or this effect is known as Zeeman effect. Okay, and star effect is just similar, but in this case, they are influenced by electric field instead of magnetic field. Okay, so when the splitting of a spectral line of any atom into a group of fine lines, group of multiple lines under the influence of electric field, this is known as Stark, right? This is known as Stark effect. So just remember this effect. So these effects doesn't Bohr doesn't explain these effects, why these effect comes into your why we observe these type of effect, Siemens effect and Stark effect. Okay, so he doesn't explain these effects, Siemens effect and Stark effect, why the multiple splitting of lines occur when it is influenced by magnetic and electric field. ओके, तो ये हमें बोहर ने नहीं कहा था, so that's the major limitation. Yeah, so just remember these three limitations of Bohr model. Clear? Any doubt in Bohr's model?
No, ma'am.
No, ma'am.
Okay, so okay, there's no doubt, so let's do this question. So what are the frequency and wavelength of a photon which is emitted during a transition from N5 state to N2 state? Okay, in the hydrogen atom. So we have to calculate the frequency as well as wavelength of a photon, right, which is emitted during a transition from N5, right? तो यहाँ पे देखो सी higher state से lower state की तरफ जा रहा है. Higher to lower means drop हो रहा है. Electron is dropped, right? So when it is dropped, then energy is evolve. Okay, energy यहाँ पे evolve होगी. Now let's calculate the energy first. See, so we know that. First, write down the question first. What are the frequency? Just write down the question and what is given in the question N5. Final one is N2, right? And the initial one is your N5. And Z is equals to 1 because it's a hydrogen atom. Okay, what is given over here? N is equals to Ni. Initial is equals to 5 and your final one is equals to 2, right? And we know that delta E is equals to, okay, let's suppose it's 13.6 into, because हम electron volt में ले रहे हैं, okay? So we are just calculating it in electron volt. You can calculate it in joule also or kilojoule also. So 13.6 into Z square 1 upon initial orbit upon 1 upon final. Okay, so we have derived this formula. Now Z is 1. So now substitute this value 13.6 into 1 square into 1 upon initial is your 5. So 5 square means 25 minus 1 upon 2 square means 4. 13.6 into 25 into 4 it's 100. Now 4 minus 20. Solve this. 13.6 into this will give you minus 21 upon 100. Right, so delta E will be minus 13.6 into 21 upon 100. Right, so no need to solve further because we have to calculate frequency and wavelength. Okay, तो यहाँ पे energy waste करने की कोई जरूरत नहीं है, so no need to calculate further. You can substitute it like this. Now see, I just told you in the previous class, when the energy is given in the electron volt, just use this formula, right? E is equals to 1240 upon lambda, right? So when energy is equals to, in electron, this is in electron volt, right? Because we have used this formula 13.6 into Z square. Now from here, the energy we have calculated, right? So let's just substitute it over here. Minus 13.6 into 21 upon 100 is equals to 1240 upon lambda. Right. Now there is no need to write down the negative sign over here, right? Negative का यहाँ पे कुछ specific meaning है. यहाँ पे negative sign आपको numericals में there is no need to write down. Okay, तो यहाँ पे आप erase कर सकते. Okay, now just calculate this 13.6 into 21. So just write it down. The lambda is equals to 1240 into 100 upon 13.6 into 21. Okay, so energy is in electron volt, so wavelength will be in nanometer, right? Now solve this. Okay, you will get the lambda value 434 nanometer. 434 nanometer. So this is the wavelength. Okay, so we have calculated the wavelength. Now tell me what is the formula for frequency if the wavelength is given? Anyone? Aisha and Sanidhi? How to calculate the frequency when the wavelength is given? Yes.
E is equal to 1240 divided by lambda.
No, it's mu is equals to c upon lambda, right? C upon lambda says the speed and
Oh,
lambda
okay.
is the vector, right?
Yes.
So you can use this formula. And what is the value of c? So we know that 3 into 10 raised to the power 8 meter per second, and the lambda value is 434, right? So c value is in meter, so you just have to convert this nanometer into meter. So into 10 raised to the power minus 9 meter, right? Further, you can solve it. 3 divided by 434 into 10 raised to the power 8 into 10 raised to the power 9. Meter, meter, it will cancel out and you will get per second. Okay, now solve this. 3 divided by 434. It will give you 0.0069. 0.0069 into 10 raised to the power 17. Or simply you can write 6.9 into 10 raised to the power 14. Right? So that's the value of frequency. Done?
Yes, ma'am.
Okay, now tell me, you want to continue the topic because the time is up. If you want to extend the class, so I can. I can complete one more topic, which is de Broglie's wave equation, wave theory. If you have sufficient energy, then yes, Aisha and Sanidhi.
Ma'am, I don't know because I'm in India currently and it's already 11 p.m.
Okay, so okay, no problem. So we will continue in the next class.
Okay, ma'am.
Okay, Aisha. So written, बच्चे?
Yes, ma'am.
Okay. So if there is any doubt from today's class, so please you can ask.
No, ma'am, not now.
Okay, so yes, Sanidhi.
No, ma'am, nothing.
Okay. So 4 more topics are left. So I will try to complete this chapter in the next class. And after that, I also need one more class to discuss the questions with you. Okay, NCERT के जो भी questions होंगे like back questions and your in-text questions, please do that. जो जो भी अभी तक टॉपिक हुआ है उससे रिलेटेड जो भी क्वेश्चंस हैं in your NCERT, just do that. And if there is any doubt, you can ask in the doubt section. Okay, I will schedule a doubt